We're learning to be tool-safe.
Watch this video to find out the safety guidelines for this equipment.
This is a printed circuit board. Anywhere there is electronics, a printed circuit board will be there holding it all together.
Printed circuit boards, or PCBs, are in all our technology, from computers to the solar lights in your garden. We will show you how to safely use the tools to make one in the classroom.
You will briefly be handling copper in this process. Copper is a relatively safe metal. However, in industrial production, workers need to be specially protected for extended exposure and handling.
In some cases, the copper is on the other side of photoresist board, a piece of glass reinforced plastic with the copper side having a photosensitive coating.
When the protective plastic is peeled back, this sensitive coating is available for our process. You would have to ensure that the PCB mask is laid with the correct orientation. Otherwise, when the circuit is etched, you will discover that the circuit is reversed.
So in that case, a UV light box and a pan of developer are used with a timer to create the pattern for etching. This has other more advanced safety training required, and the MSDS sheets must be available for the developer chemical. Usually, your teacher will complete these steps with students standing by.
In other classrooms, we use plain copper and follow a different procedure to apply an iron-on transfer. The first step is to cut out the transfer. Cut along the thin line.
Remember to check if they are left-handed or right-handed scissors. When using the scissors, remember to focus on the task at hand. If you want to look up, simply stop cutting. Cut in a direction away from your body, fingers, and hands. If you are giving someone the scissors, pass them handle first.
Next, using a pencil, trace out the pattern. Make sure you strategically place the transfer in the corner to not waste material, and check the orientation so nothing is reversed or upside down.
Now it's time to cut the copper board. Have you checked your measurements and specifics for the project? We're using the foot shear to do this. Ensure you have done the proper safety training and completed your instructor's passport for using the foot shear in your classroom lab.
Make sure the table is clear of all other materials. Place the copper board up against the right angle guard. Then, slide the board until the pencil mark lines up with the cutting edge of the table. Make sure that your hands are well back from the pressure foot.
Then, place your foot on the treadle. Make sure your other foot is clear of the treadle. When ready, push down on the treadle with one firm motion. Ensure your hands and fingers are positioned safely away from the blade compression pinch point.
Now that we have the copper board to the right dimension, we'll take a copper pad and clean the copper until it's shiny.
The next step is to iron on the transfer with a clothes iron.
This is a very hot tool, and if safety precautions are not followed, someone can be burned. All ironing will be done on a wooden board. Make sure you check the electrical cable for fraying and handle the plug properly. Check for the correct temperature setting and application time in advance with your instructor.
Make sure that the cord is positioned so that nothing can catch and pull on it. Having a hot tool being pulled out of your hands with a trip or slip or inattention could result in a very serious burn.
Preheat the copper wrapped in a paper towel for approximately 4 minutes to ensure that the transfer goes well. Use good ergonomic position when operating. Leave the paper towel surrounding it so that it is easier for the hot iron to slide and not scratch the surface. Make sure the text on the transfer is facing you so you can read it properly. Use heat protective gloves to handle hot copper pieces. Have a cool water bath ready to go to cool it after the transfer is done. Turn off the hot iron. Face it away while it cools. When the iron is not in use, make sure that the iron is standing up and the hot sole plate is facing away from the person using it.
After we iron on the transfer and have fixed any imperfections with the permanent marker, it is time to etch the board.
We use ferric chloride to etch the copper board. This is very corrosive, and if it gets in contact with your skin or in your eyes, it can seriously damage the skin. Ensure you have the MSDS for your specific product on hand.
In most cases, your instructor will be putting your board into the etching tank and taking it out. You should be watching the process for the time it is in there.
When working with or around ferric chloride, you must wear your personal protective equipment or PPE. That includes safety glasses, a plastic or vinyl apron, and plastic or vinyl gloves. Any splashes must be cleaned up immediately and rinsed off clothing and skin. Have cleanup materials ready. There should be no food or drink in these labs.
After taking out the board from the etching solution, it needs to be washed following the instructions of the teacher. Again, if any specialized chemical solutions are used in your classroom, you must have the MSDS handy and understood to follow the right procedures. A PCB eraser can be used to remove any film from the tracks, so your plans to solder work well.
The last step in making your PCB is the drilling of holes for your components. We will be using the drill press. Sometimes a special small PCB drill is used for this step. Even though it is small, it can still do a lot of damage if not handled properly.
When completing any drilling, follow these safety measures. Check the quality of the cord or power supply. Wear safety glasses.
Put your devices away.
Do not wear loose clothing when operating the drill press. Stand in a safe, solid position and be careful in your action. Ensure you have marked where you will be drilling and compare it to your diagram plan.
As you bring down the drill, prepare for the breakthrough point by easing up on the lever. The board must be properly clamped to keep it from moving.
Do not use dull bits and don't try to apply more pressure, as this can slip unexpectedly and/or damage your board. Tell your teacher if the bit is dull. Review the manual for the drill.
The last procedure is to clean up from all operations, sharp cut debris, chemicals, tools, and work areas. Make sure you wash your hands. Okay, now for a toolSafe review.
Know the different ways that PCB etching procedures can work. Know safe handling of metal shears, hot irons, and drills before starting this project. Be aware of what chemicals are being used in your process and have relevant MSDS.
Wear all protective gear while in the shop, especially when handling chemicals. Follow timing procedures. Clean up each area of the process before leaving. Notify your teacher of any injuries or spills, no matter how small. Be familiar with your nearest eye wash station.
And if you're not sure about anything for safety, ask your teacher for more direction.
And don't forget to be tool safe.